Hey there, AP Stats kids. Today I'm going to be doing a review of Chapter 2. This is going to be dealing with stem plots, normal distributions, percentiles, all sorts of fun stuff. Alright, just like all the other videos, if I were y'all, I would pause it, try the problem. You can use this website too if you want to actually have a printout copy of it and try it and then check it. From Mrs. Daniels. Thank you, Mrs. Daniel. Danielle, maybe? Danielle. Alright. So, we're looking at a stem plot. Here's our stem plot. What are the percentiles for each of the following teams? The Colorado Rockies, who won 92 games. So I go up, that's my 92. And then I count how many teams had less than 92 wins. I don't feel like counting. So you can count on me to be cheating. And I counted 24. So the percentile is 24 out of 30, which is 80th percentile. Now let's look at them Yankees, who won 103. Alright, how many teams did less than them? Well, 29, of course. 29 out of 30. Puts them at the 90-something percentile. I didn't write down the answer for that one, but that's how you'd find it. Alright, guys, this is real professional stuff. Professional baseball, actually. Alright. Let's keep scrolling. What about the Kansas City Chiefs? Royals. The Royals and the Indians, who both won 65 games. Well, if you look up there, they only beat 3 of the teams, and 3 out of 30 would put them at the 10th percentile, right? Alright, cool. Any questions? Raise your hand. Alright, put your arms down. Hopefully you're still being cleanly, or else you probably armpit smells. Alright, so let's look at this beast. Zoom out a little bit. Alright, so we are going to look at the median household income for the 50 states and the District of Columbia. So there's going to be 51. And we want to find the relative frequency and the cumulative relative frequency. Now with relative frequency, we're just comparing it for that one data unit. With cumulative, we're going to be adding up and dividing by total. So, for example, there was one state whose median income was between 35 and 45. My relative frequency is 1 over 51, which is about 0.02. Alright? My cumulative frequency is also 1 over 51, which is also 0.02. Now, for relative frequency of the 40 to 45, I do 10 over 51, which is about 0.196. Now for this one, I'm going to take the 0.02 and add it. Or I'm going to take the 1 plus the 10 to get 11. 11 over 51 is 0.216. Alright, next one I'm going to do 14 over 51 for relative frequency, which is 0.275. This one I did 14 plus 11 is 25. 25 over 51 is about 0.49. Alright, now I'm just going to go through and put the answers down for y'all. Down here there's going to be another answer that's 0.059. And over here I'm going to get 0.725, 0.824, 0.941. And whenever you do cumulative frequency, your last one should always be 100% or 1,000, 1.000 cumulative frequency. That means you did it correctly. You could have done as percent, you could have done many different ways. Let's look at this graph, Dealio. Alright, so here we're looking at cumulative frequency. Again, pause it, try it. So we're looking at what percentile, answer in 3, 2, 1. California has a median income of 57.5, so about right here. So I'm going to draw a line up, put a dot, come across. It looks like their percentile is about 79-ish. So 78, 80th percentile. Both those are probably acceptable responses. Now let's estimate the first quartile solution. First quartile is 0.25, 25%. So go to 25%. I get about $45,000 median income. We good? Last problem. Go ahead and read it. Pause it. Try it. Love it. Like it. Want some more. Love it. Alright, so if you give $1,000 raise, what's it do to the mean and median? Well, they both go up $1,000, right? Because if everything's going up, the mean and median are affected by adding, right? Because we're taking the curve and we're just moving it over, right? It's the same curve. That's creepy. Don't do that. That's supposed to be the same curve. I'm sorry, guys. Now, if we give $1,000 raise, what happens to the standard deviation? Nothing, because spread is not affected by it. So they will be the same. If the average standard deviation between salaries was 1,000, and you move everyone up 1,000, the spread is the same. It'll still be 1,000. I don't know why I used 1,000. That's a terrible example. This is a bad video. It's just a bad video. All right, more stuff to learn. Again, pause it, read the question, try it, and see what happens. All right, so we're looking at Major League Baseball. We have a mean, standard deviation. Yankees, then we put their number minus the mean over the standard deviation. Oh, answer coming in 3, 2, 1. Sorry, no warning. Sorry, y'all. And I got 1.93. Now, to interpret that, you would say the New York Yankees had 1.93 standard deviations above the mean number of wins. Okay? Now let's do the Metis. They had 70. So again, I'm going to take their number minus my mean over my standard deviation. I got negative 0.96. So if I'm interpreting, I would say the New York Mets were 0.96 standard deviations below the mean number of wins in Major League Baseball for the 2009 season. Let's look at this beast. Pause it. Try it. See how close you are. Answers coming in 3, 2, 1. So I draw a normal curve. I put my mean in the middle. Go 1, 2, 3. 1, 2, 3. Now each of these spaces is one standard deviation, so 0.034. Above and below. So that makes this one 0.295, and this one 0.329, and this one 0.363, and this one's 0.034 below, so it's 0.227. This one's 0.193. This one's 0.159. Now let's look at this. How many are above 0.329? So I'm going to 0.329 and find the area under this curve. Now if you don't remember that, you can look at this. So 0.329 was 2 standard deviations above. So 1, 2. So you're looking at 2.35% and 0.15%, which is 2.5%. So 2.5% of people hit above 329. All right. All right. How many peeps hit? So that's 2.5. How many hit between 227? That's my highlighter. 227 and 295. Well, that's one standard deviation. So right away you should be like, "Yo, dog, that's 0.6. That's 68%. And that's by the empirical rule, right? One standard deviation, empirical rule. If you forget that, remember 68, 95, 99.7, right? 68, 95, 99.7. According to the CDC, Center for Disease Control. Well, heights. We'll pause it, read it, try it. You will need a calculator to do this one correctly. All right, answer coming in 3, 2, 1. Third quartile is your 75th percentile, right? So whenever you have a percentile and you need to find a number, you're doing inverse norm. So I'm going to inverse norm 0.75. That's always mean standard deviation, right? So I'm going to do 94.5, 4. And I got 97.2 centimeters. I'm not drawing the curve, sorry. But it looks like this. 75% is filled in. What's the median? Median's halfway, right? Guess what? Median mean should be the same thing in normal distribution. So it's just 94.5 centimeters. Boom. All right. You have a 3-year-old who's 91.7 centimeters tall. What percentile is she in? Now I'm finding a percent. So I'm going to do normal CDF. And now I'm doing percentile, so it's always below, right? So we go negative 999 to 91.7 to my mean, to my standard deviation. And when I plug that in, I get 0.24. So she's in the 24th percentile. Okay? A mother knows her daughter's 91%. How tall is her daughter? I have a percentile, I need a number. Inverse norm. That's in second distribution, y'all. Just like how we did number 1, right? And I got that shorty's in the... Oh, I'm sorry, that shorty is 99.86 centimeters. Okay. All right. That's where I'll leave it, guys. Hope you learned something. If not, I'm sorry. Have a great day.